So we're going to be making ethyl ethanoate, which is an ester, and it's part of the higher level GCSE chemistry course to know how to make these. It's the only one that you actually have to know the name of. So where do we get our ethyl from?
Ethane.
So ethanol, yeah. And our carboxylic acid that we're using is
Ethanoic acid.
Ethanoic acid, which is obviously vinegar. We're using white wine vinegar. We haven't got much of it left, as you can see, so we're somewhat limited by that. This is our conical flask, as you know from past videos that we've made. If you've watched any of the others, we obviously buy these made with real fruit inside from the supermarket shelves. These little beakers that we've got down here, which I'll just angle the camera down a little bit so you can see. So these little beakers that we've got down here, we've also bought from the supermarket, containing food products. And this one here, this is the only thing that we can't get from the local supermarket, which is a hydrochloric acid. Why do we need the hydrochloric acid?
As a catalyst.
As a catalyst, right. What happened to your safety glasses?
What safety glasses?
The safety glasses that I gave you earlier to put on. Yeah, I know, just like all students the world over, you hate wearing your safety glasses because they make you feel stupid. Okay, no, your forehead doesn't need protecting. It's your eyes that need protecting, please. Okay, so we're wearing glasses over our eyes because we've got hydrochloric acid today. Obviously, the alcohol, which we bought from the supermarket shelf earlier, there we go, and the vinegar, which was also bought from the supermarket and not a problem. The ester that we're going to make, ethyl ethanoate, is also something that you will regularly come across in the supermarket. You will recognize the smell when we make it. Are you ready for this?
I mean, they won't recognize it because they can't.
No, you're going to have to describe what we've done. Okay, so and you're going to have to describe this change in smells, which might be a little difficult because we've got the slow cooker on at the moment. No, we're going to mix it in the conical flask, and we were going to measure it using the pipettes, if you remember.
It's fine, just wing it.
Just wing it. Okay, well, here you go. Here's some pipettes. We're going to try and put this about the same amount of the ethanoic acid, which is our carboxylic acid, as we put in the ethanol, okay, which is alcohol, and we're expecting to get ester and water off them. Now, it's 1 molecule to 1 molecule reaction ratio on them. Okay, so try and we'll use a different pipette because we don't want the reaction taking place inside the pipettes, and try and put the same number of pipettes full into there.
I lost count.
Okay, I'll trust you to gain an idea of how much it was then. Can you see anything happening in there? Just so I think the colour's changing slightly. And still smells of vinegar. Okay, so when we're smelling the stuff, we don't sniff directly into the tube. We do the chemist smell, which is to waft the smell with your hand towards you. Do you want to have a go? No. Well, you don't want to have a quick sniff of vinegar. Okay, so I'm going to pour the hydrochloric acid into the beaker that we've got, and we're using a different pipette again for that. So there's a small beaker. Okay, we shouldn't need too much of it. It is our catalyst, and it's supposed to be fairly strong. This is stronger than bench concentration, so I'm going to hold the pot so it doesn't do anything stupid to you and try and jump off the table and burn holes in people's socks or anything like that.
And arms.
Yeah. It should be okay on skin. It will tend to attack your clothing more than your skin, this will. As long as we're right by the tap, which we are, and we rinse it off very rapidly. It shouldn't be too much. It shouldn't be a problem at all, actually. And of course, you don't get it in your eyes, which is one of the reasons why we use the conical flask, because the conical flask is obviously, it's narrower at the top, so it's more stable, and it also reduces any splashing up, because splashing up should hit the sides of the jar. Okay, shall we have a look now? So we'll give it a swish. Okay, you can stop adding. I'll put that away from the edge. Now we've got a completely different shaped beaker for that one, so we don't get them mixed up. Now, okay, I'm looking down in there and I'm seeing, firstly, we've got a colour change. And secondly, can you see, if you come down here, you can see there's a precipitate forming.
Yeah.
Okay. So we've got a decent precipitate forming. Okay. And let's see if we've got a change in smell. Well, I can't smell the vinegar anymore.
I can smell the vinegar.
Okay, so the vinegar smell is still there. Do you want to put a bit more acid in to see if we can encourage this along a bit? Of course, as with all chemistry reactions, you probably have to sit here and wait for it to take place. The only problem with doing this experiment at home, guys, is the lack of acid that the strong acid that you. Can we get the 2 cups closer to each other so we're less likely to get spillage on the counter? Thanks. It's the lack of strong acid is your big problem, and looking for places where you can get strong acid from, you're probably going to have to go down the drain cleaner route, which is a very strong acid. Okay, you can stop there. So again, we're going to... Now the vinegar smell, if you'd smelt it before, you'd have noticed that the vinegar smell was actually quite strong. It was the same as you're getting from, there's the empty beaker of the vinegar. It was like that. Okay, so if I put that over there, don't stick your nose straight into it because you've got hydrochloric acid in there, which could be giving off chlorine. We have got the door open, by the way. So yeah, I've just turned the cooker on and off with my elbow. We have got the door open, and a window is partially open at the other end to give us plenty of ventilation, because obviously it's all about the ventilation these days. Yeah, I mean, what we've got there is we've got the precipitate. We've got a precipitate forming, which is our ester. And we've got a change in smell. Now, the thing to do would be to evaporate that off. Okay, so if we evaporate that off over a period of time, we can either evaporate that off by boiling it or evaporate that off by just leaving it out in the sun and hoping that's going to be okay. And I've got